Hello, everyone. Today I'm going to hold this technical talk related to cross-platform development with Kotlin Multiplatform. Today we'll dive into theory and live demo. And if you don't mind, let's wait a couple of minutes for someone who wants to participate in it as well. During waiting some time, let me introduce myself. My name is Siarhei, and I'm a software developer and resource manager at Andersen, over 8 years of experience, and mainly focus on the Android software development as well as cross-platform mobile development. Also, I'm keen of contributing our community with publishing some articles connected with my insights and sharing knowledge on Medium, Pro Android Dev, and IJCA. So this is our plan of the presentation. Initially, we introduce the presentation, then we'll switch to theory, KMP architecture overview with advanced KMP features. It is highly important to describe some features before we'll dive into the real projects. Talking about advanced KMP features, we will discuss the following things like expect actual mechanism, dependency injection, sharing resources, and much more. Then we'll go through the practical example connected with two applications, Rick and Morty KMP and MusicApp-KMP. After it, I will share some resources and useful links, and we'll have a chance to hold Q&A session. Before we switch to the main part, let's emphasize our purpose. So the main purpose, I would split it into parts. The first one is to understand the theory, and the second one is to meet on the real world applications. All right. Now that you know a little bit about me and our goal of this talk, let's switch to the real part. So the main problem during developing for mobile applications is that when we have a common code base for which are being developing for two applications for iOS and for Android, and obviously it leads to some kind of problems. The first one, it is connected with cost. So it leads to increases the cost of development. The second one is connected with increasing account of bugs. Why KMP? The short answer is that KMP resolves the issue. So firstly, it allows us to split this common code base into the shared module. And secondly, KMP allows us to keep platform-specific UI, which allows us to avoid facing some kind of problems connected with platform-specific. Now let's compare Kotlin Multiplatform with Flutter and React Native. First, it allows us to leverage native UI components. And secondly, it reduces the risk of platform-specific bugs in the shared logic. On the other hand, Flutter and React Native can speed up UI development since they provide a single code base for everything. However, again, we always have to keep balance between these two solutions and understand the risks and pros and cons for both approaches. What makes KMP unique? So yeah, a couple of things I would say. The first one is connected with full native UI. So we still can support Compose, Swift UI, UIKit, and Jetpack Compose. The second point is about sharing business logic. So we can split and share really what we need to split and share. And this is a big thing I would say. Another point is that KMP works well with existing code base. So it allows us to not develop the application from scratch, but do that. So, but use so-called gradual approach. We will return back to it a little bit later. So yeah, let's start by looking at the overall architecture of Kotlin Multiplatform and how its main components fit together. So yeah, this illustration shows us the main concept. So at the middle of this image, we have shared code. Usually consists of domain layer, data layer, networking stuff, business logic, and so on, while Android and iOS communicate with this shared code. In the meantime, we have some UI specific things which remain to be platform specific. The same thing for SDK integration. So sometimes we have some SDKs which are integrated into our application. So these SDKs are also connected with platform-specific modules. The next schema illustrates the same thing, but a little bit more details. Here we can see the messaging data flow. So we can see how Android or iOS message with the shared module, and we can see what particular layers could be placed into in the shared module. So talking about benefits of this architecture, I would split in a couple of them. The first one, it reduces code duplication. As I mentioned before, the problem. The second, it ensures consistent behavior across platforms because we have UI components placed in the platform-specific modules. And this architecture supports incremental adoption. So incremental adoption or gradual adoption, what does that mean? So the key idea is to start small. You don't need to, as I said before, develop the application from scratch. You can just implement a couple of small features or sensitive components in the shared modules, and step by step expand the shared module to the full application. In this section, we'll focus on advanced Kotlin multi-platform features that extend its core architecture and improve scalability and integration. So yeah, the first code snippet illustrates the full concept of expect actual mechanism. As you can see on the shared module, we apply expect method or a class, doesn't matter. And when we need to reapply it, behavior or logic, doesn't matter again, we do the same and wrap it as actual on Android or iOS modules or other kinds of platform-specific modules. The next sample illustrates the dependency injection mechanism. In particular, here we can see the coin as the most preferable tools in KMP. Actually, it is more about service locator, but doesn't matter. So yeah, here we can see how it works. We apply a module we can apply inside this module singleton objects or usual instances, doesn't matter again. And highly important to say that we need to call start coin method from Android or iOS startup modules. And here we can see the combination of dependency injection and actual expect mechanism. Sometimes we need to not only bind some dependencies in the shared module. Sometimes we need to bind platform-specific components. So this example demonstrates. So we have a logger, and depending on a particular platform, we would do that differently. So like this, we can make it actual for Android and for iOS as well. For Android, we here use util.log. For iOS, we are using here nslog. Talking about sharing resources, we can share not only code base, but actually also strings, images, colors, and other stuff. For platform-specific needs, we can use expect an actual mechanism as well when we need sometimes something specific from a specific platform. Talking about testing, so again, for when it comes to the common module or shared module, we still keep one common module for testing, which names usually common test. So in this, to do so, we can use JUnit, Kotlin.test, and other libraries as Android developers are familiar with. Talking about UI testing, the story is a bit different because UI usually are connected with platform-specific modules. So that's why we are using other tools. For Android, we are using Espresso or Compose UI test. For iOS, XC test or XCUI test. Right. So yeah, it is hard to imagine an application nowadays which doesn't use networking. So that's why it is highly important to emphasize some specific tools for KMP, and this is KTOR, really rich mechanism allows us not only communicate with networking, but also it allows us to configure serialization, JSON serialization, login, and so on. Talking about local preferences, we should do that using the expect actual mechanism again. So obviously, Android part uses shared preferences, while iOS uses NS user defaults. So that's why we have to implement these component for particular platform. For example, this example illustrates so. As you can see, for Android actual class, we are using here shared preferences, while for iOS here we are using NS user defaults. When we are talking about iOS-based specific components, sometimes we have so. We can use some specific compose components. Obviously, we want to implement fully the entire application, but sometimes we can't do that. So that's why we can use the following mechanism. So as you can see, this example here, we applied UI kit view with a lambda with two lambdas for factory, which allows us to reapply UI text field here, and the update mechanism for targeting a particular, in this particular example, it is connected with on text changing. So that's how it works here. To wrap things up, Kotlin Multiplatform provides us a solid variety of toolings, such as expect actual, which enables us to create some kind of bridge between the shared module and platform-specific ones. Dependency injection, which simplifies modular architecture. Shared resources, again, allows us to share some common resources. Testing, again, local preferences, and some possibility to use native iOS views. So yeah, right. Now we are familiar with the theory a little bit, at least, and currently we're ready to delve into the real projects. The first example is Rick and Morty application, a client built with Kotlin Multiplatform, showcasing shared networking, data storage, and logic across Android and iOS. Now I'm going to switch to my IDE, Android Studio. Initially, I want to pay your attention to the structure. So as you can see, we have Android and iOS specific modules, and we have the shared module as well. So that actually works similar as we are familiar with already. We have, for Android, we have the application where we can configure some components. For example, coin implementation is needed here. The same story is for iOS. We have the main controller, which is an entry point into our application. I forgot to mention about main activity. It looks like this. Another important thing I want to pay your attention is that we apply here this main component, composable one. And the same story is for iOS. We applied this main component. And this component actually is from goes from the common module, which is actually the shared module. It has some UI basic functions, composable ones, for theme, for context. It is not interesting here. And finally, we invoke the navigation host. This navigation host consists of only two screens. Our application is not so big. The first one allows us to see the list of characters from the movie, and the second screen allows us to see their details. Also, highly important to mention that we are using here, since we are using here the modern approach related to nav host, we are using also composable approach, and to navigate, we here applied this lambda. Here we listen to it, and when we obtain a particular character, we navigate into the next screen. The next screen, this one. Also, as you can see, it has a lot of animations. So actually, it is easy to implement and quite comfortable to use it here, right here. So yeah, let's go through the first screen. The first screen, as I said, allows us to see the list of characters. It has a view model, and here I listen to these particular events or states. For example, type in particular characters and so on. Then I have some kind of animation for initial purposes, and here I handle this full state. Next, let's go to this view model. Yes, not this one, sorry. This one, yeah. This view model has a repository, and by using this repository, I obtain characters or details of characters, obviously. So what is interesting to see here is that we use event-based approach when we send some kind of events, and by listening to event stream, we handle it. Yes, let's go to the repository, which is an interface. And this is the implementation. For Android developers, I believe most of the Android developers are familiar with this approach. We are using here Flow, paging data mechanism, and actually all of these things are absolutely the same. So that's why talking about Android, it is easier to migrate to KMP and gradually, step by step, expand this common or shared module. And finally, this repository operates by using this API client, which is actually some kind of wrapper who operates using the Ktor client. So it just gets an easier API call, obtains some kind of characters, and serializes it to the real object. Now, let's try to run it on the Android device firstly, and let's see how it works. All right, this is our initial animation. Another animation when the screen is opened, and we can see this list of characters, which is actually being loaded during scrolling. To open details, just click it, and we can see some episodes connected with this particular character. Okay, let's do the same for iOS. Yeah, highly important also to mention that we don't have any opportunity to do it from the Android Studio, unfortunately, at this moment, and we have to do it using the Xcode. Yeah, so let's run it again, but only on the iOS emulator. Yeah, it's in progress to build. Let's wait. Yeah. So as you can see, the animation is absolutely the same. So we don't need to support it twice or spend some additional effort to do that. And the same story is for details. So the application works fine for both platforms. Okay. Let's return back to my presentation that was about Rick and Morty KMP application. And for now, the second project, MusicApp-KMP, demonstrates a more advanced use of KMP, integrating platform-specific media APIs while keeping the business logic fully shared. Let's return back. Let me change the AD. And yeah. So talking about the structure, it is similar. We are familiar already with this. Again, we have the entry point for Android, and the same story for iOS. So again, in the application, it has some kinds of configurations. And in the activity from Android, it has some Android-specific things. So in particular here, we have applied some permissions in order to see the files, in order to operate with them, because we need to play them. And finally, it refers to the main Android file. Yes, so this is about this one, and let's take a look at the iOS. So yeah, this main, yeah, that's right. It has the main common component, as well as iOS does absolutely the same. Also, both of them have some UI components, but actually it's not interesting here. And finally, we can see the main common component from the shared module, common main. So again, it has some theme component, boxes, children, and so on. But the most important UI part here is this player view, which allows us to operate with media files. This player view is also part of shared module, and it has this player component. This player component consists of, obviously, with view model and some classes connected with output or input classes. So yeah, here we can see the UI logic, which is quite complex, actually. Yeah, by using this view model, we can operate our media files. For example, play some tracks, returning back, set buffering, and so on. Let's go through the view model, which is responsible for operating it and keeping the state for UI. So yeah, you can see here this player view state, which is the main one. And it has some kind of listener in order to handle all the events which are being responded from the particular players. Let's go. Yeah. Also, let's take a look at how we So yeah, here we make it prepare it and apply this listener to this controller. Then let's go to media player controller, and here, as you can see, interesting part that because we use here expect, we make it as expect one, because actually, in order to operate the media files, we always do that using particular platform-specific components. So yeah, that's why we here applied some kind of contract, and by using this contract, we make particular instances for these contracts. For example, for Android, and for iOS as well. Also, you could notice that we have more implementations for GS for desktop, and KMP does support them, but this is out of our context of this presentation, so we here focus on the mobile part only. Yeah, let's take a look from the Android one initially. So as you can see, it is actual already, and we here applied the main component player, which is actually the EXO player. So again, the most of Android developers are familiar with this, worked early, and knows how it works. So by using these component, we can add a listener in order to listen to it and understand what is going on. And the same story for managing its state, like playing some tracks, playing another one, and whatever. And the same story for iOS part. Here we have applied also this player, and here we are using AV player, which is iOS specific one. So what's also important to say here is that we, as you can see, apply the contract and support it. So, but actually the implementations differ. Yeah, let's run it and see whether it works correctly. So the application works at least, and let's play something. Okay. So yeah, while it plays and works fine, unfortunately, you will not listen to it because due to the YouTube policies, we can't retranslate the music, unfortunately. But just trust me, it works fine. And let's do the same for iOS. Just run it, and let's wait for a while. Okay, also works fine. All right, music, this track plays again correctly. But again, unfortunately, you will not listen to it because, again, we have some restrictions from YouTube. That was about this practical example connected with MusicApp-KMP. Yeah, special thanks to Beatrice for allowing me to share the Rick and Morty application. So if you are interested, you can you can reach the these resources, the open source project, and LinkedIn link as well. And the special thanks to Abdul for permitting me to showcase the MusicApp-KMP project as well. So again, all the links have been attached. If you'd like to connect to me to continue this conversation, feel free to reach out to me on LinkedIn as well. And yeah, for more insights and resources, you can also explore the materials provided by Andersen. And yeah, that's actually end of this presentation, and I'm happy to take any questions if you have. For this, I'll going to check our chat. A warm note is that now on the last studio we can actually run the KMP for iOS. So yeah, so sorry for this inconsistency. Unfortunately, I missed this news. That was my bad. But yeah, I will definitely check this feature. It is exciting one because currently and previously it was not useful to switch between EDS, and yeah, it was annoying. The next question is, what do you prefer, KMP, Flutter, React, and why? Actually, in order to answer this question, it is highly important to emphasize and extract a particular business expectations. Sometimes business expects from us to provide fully covered cross-platform solutions, and in this case, would be better to consider between React or Flutter. Again, the same thing is connected with whether your team are familiar with JS or Dart. So the same story. In the meantime, sometimes we'll need we are familiar with Kotlin, and in this case, I would prefer to use KMP. So unfortunately, I can't answer it directly. So KMP is better than Flutter or vice versa. So it is always a compromise. Which IDE support KMP? Currently, Android Studio definitely supports that. Probably we have something new, but unfortunately, again, can't answer it. What we have, which kind of alternative we have beyond the Android Studio. So at least definitely Android Studio. Are you using Coin? What about Hilt for KMP? So again, for KMP, I'm using usually Coin. Talking about Hilt for KMP, to be honest, I didn't use it early, in particular in KMP. but obviously I use that for Android development. Talking about comparison between Coin and Hilt, again, it is always a compromise, because since Coin is a service locator, it has their pros and cons, and the same story for Hilt. Again, it is highly crucial to understand the business expectations. Sometimes we need to reduce build time. In this thing, would be better to consider Coin, and sometimes we need to reduce runtime working. So again, it is always a compromise. I don't have my my favorite tools or something like that. Okay, it was the last one. Let's wait for 1 minute whether we have one more. Yeah, we have one more. What do you prefer for UI, Compose or old XML? So probably under old XML, meaning classical views. Actually, if I develop a project from scratch, I would prefer to use Compose because it has several benefits. Firstly, it is declarative approach, which allows me to use it easily and so on. Secondly, it has resolved the issue which was connected with early views. Actually, this story would be a little bit longer, but anyway, what is the problem? The problem is related to two problems actually with views. Initially, it is connected with that fact that views currently are GAT objects. If you open the views, you would see thousands of strings, and it is harder to support. And secondly, views actually destroys the singular responsibility, because views are responsible for uh, how to say restoring its state and redrawing itself. So that's why Compose, from my perspective, is better. However, we still have a lot of legacy, and sometimes it costs more. It costs more to rewrite from scratch to Compose than support previous code base. So that's why it is always a compromise. Okay, let's wait one more minute. Okay, I have one more question. Do I need to use native Swift UI anywhere in native project, or they are written with Kotlin lang? So it depends again on the situation. Sometimes, and I actually have already said about this point, we have some components which are not supported by the Compose. And in that case, you will need to make some special techniques in order to call inside the Compose component your native iOS-based code. In the meantime, we now have the Compose, which allows us to write all the components for iOS as well. Okay, still waiting for some questions. Yeah, still waiting for some questions. This moment looks like that was the last one. All right, looks like that's it. So again, thank you so much for participating. I really appreciate it, and I hope we'll see you next time. Thanks again, and have a good day.